What's up, guys? Andrew Steinmetz, QA/QC manager here with Genco Inc. Coming to you with the part 2 of my series on motor calculations for the electrical exam, steps 3 and 4. If you haven't seen the first video in this series, please go back and watch it. Step 1 is crucial for the rest of these steps, so you'll need to go back and watch that video before watching this video. So let's just jump right into it and get into motor calculations for the electrical exam, steps 3 and 4. So as always, have your code book out and ready to use. You're going to need to use the tables in the book and follow along with me. That way you can solve these problems to help you find where to find these answers in your book. Step 3 and 4, the tables that we will be covering. Step 3, branch circuit ampacity. Article 430.22 for single motors. You'll also need table 310.16. Step 4, breaker sizing in branch circuits. Table 430.52, protection devices. So make sure you're ready to use those tables and let's move forward. Step 3, find your branch circuit wire ampacity. 430.22 single motors. Conductors that supply a single motor used in a continuous duty application shall have an ampacity of not less than 125% of the full motor full load current rating as determined by 430.6A1 or not less than specified by 430.22A through G. So basically this is very simple. You're just going to get the FLC and you're going to times it by 1.25. And that's going to give your answer. It's 25% over the 100% full load current. So another part of step 3 that you'll need is table 310.16 because they will refer to the wire that you would use. So if they bring up THHN and want you to find what gauge wire you would use for the ampacity, then you would pull up 310.16, and on the left is copper, on the right is aluminum and copper clad. All you do is take whatever they tell you. If they tell you to find TW, go right down the line, match the amperage, and of course, if the amperage doesn't quite match up, you go to the next one, just the next step higher. So right there's your gauge sizes on the left sides, gauge 18, 16, 14, 12, 10, 8. So then you just match up the amperage of the installation that you need. So let's jump right into a question. Step 3, questions. What ampacity is required for the branch circuit for a single phase, 5 horsepower, 220 volt motor? So again, going back to step 1, you're going to go to table 430.248, full load currents for single phase motors. Right, so we got a single phase motor, 5 horsepower, 220 volts. So we're going to go down the line there. We're going to find 5 horsepower, and then we're going to go over to 230 volts because if you remember, 220 to 240 is always going to be at 230 volts in that row, and we got 28 amps. So then we take the 28, we times it by 1.25, we get 35 amps. And that's your answer. So what ampacity is required for the branch circuit for a 10 horsepower, 208 three-phase motor? I'll pause just for a second. You can pause the video, look up the answer for yourself, and then we'll continue on with the answer. So go ahead and pause the video now. So you get 30.8 times 1.25 equals 30.85 amps. There's your answer. Here we go. What size wire is needed for a 3-phase, 40 horsepower, 440 volt motor using TW insulation for the branch circuit? So this is where you know that they're asking for the wire size of TW insulation. So again, the first thing that we're going to do is we're going to find the full load current. And this is a 3-phase motor. So you're going to use table 430.250. You're just going to go down the line, find 40 horsepower, and then go over to 460 volts. That gives you 52 amps. You take 52 times 1.25, you get 65 amps. Now going to table 310.16 to find the wire, we're going to go in the type TW on the left for copper. We're going to go down the line and we're going to see that number 6 is only 55 amps. So we got to go to the next step higher, which is 70 amps. So you're going to have a number 4 TW, and that's the right answer. So here's another question for you. What size wire is needed for a single phase 3/4 horsepower 110 volt motor using TW insulation for the branch circuits? Again, pause the video, look up the answer for yourself in your book, and I'll pause for a minute so you can find those answers. So what you find is 13.8 times 1.25 equals 17.25, which is going to give you a number 12 TW wire size. So step 4, what size branch circuit breaker do we need? Tables we're going to use is 430.52 gives the multipliers for different style breakers. So you take the FLC times it by the percentage, it will equal the breaker size. Then you go to 240.6a, and this is the table where you'll find breaker sizes. If the answer is not a standard breaker size, you go up to the next size available. So here we have 430.52. So you'll see there types of motor on the left-hand side, single phase motors, AC polyphase motors, squirrel cage, design B energy efficient, and so on. And then table 240.6a. These are standard breaker size, fuse breaker sizes. An easy way to remember how these work is it goes by 5s up to a 50 amp. And then after that, it goes up by 10s to 110, and then goes up by 25s up to 300 amps. So that's just a pattern that these breaker sizes have. It may help you remember it, but using the table, and it's always available, is the easiest way. Question number 1, what size dual element fuses is required for branch circuit protection for a single phase 5 horsepower 220 volt motor? So again, going back to 430.248, you're going to go ahead and look at that, find that the 5 horsepower at 230 volt, 220, 230 is going to be 28 amps. Now what you want to do is you want to go to 430.52. We're looking at single phase motors, and then we want to go over to dual element because that's what it's asking for, dual element fuses. So our multiplier is 175%. So you take 28 times 175%, 1.75 equals 49 amps. If we go to our standard amp rating sizes, you'll see there is not anything at 49 amps. The next one up is 50 amps. So you're going to need a 50 amp fuse. So here is another question. I will let you pause the video so you can look up the answer for yourself. So pause it and we'll come back and I'll give you the answer. So you're going to find that it's 30.8 times 300% equals 92.4 amps, which the next amp fuse size is 100 amps. Next question, what size inverse time breaker is needed for a wound rotor single phase 3/4 horsepower 110 volt motor? Go ahead and pause now. So you got 13.8 times 150%, 1.5 equals 20.7 amps. Next breaker size is going to be 25 amp breaker. What size instantaneous trip breaker is needed for a 3-phase 40 horsepower 440 volt squirrel cage motor? Go ahead and pause now. $52 times 800% equals 416 amps. Next breaker size, 450 amp breaker. So that's what we got for steps 3 and 4. Tune in for my next video on steps 5 and 6. Feel free to go back and rewatch these if you didn't quite get it. But it's fairly simple as long as you have the FLC. Step 1 is always used in all of these calculations. And it's just a matter of looking them up on the tables and finding the correct sizes and wire and breaker sizes. So hope you enjoyed this video. Hope this helped. Tune in for the next video on 5 and 6. Thank you.